Today is going to be my first test of my packed bed reactor that I've built over the past 4 days and done a lot more research before that. But today I'm going to be running steam through the reactor just to test if the heating and the pump works. I know both work already, but if they work together. Tomorrow, or maybe the next day, if this test is successful, we're going to be doing steam methane reforming next. And for that, I have 3 inches of the reactor filled with silicon carbide, like grit that you use for like rock tumbling and stuff like that. But it's like the perfect packing material because it's very thermally conductive and it doesn't react with anything. So that's going to be the preheater to our reactor. And for the remaining 9 inches of the reactor, I packed in some copper mesh, and that will be the catalyst for the methanol reforming tomorrow. So right now, I did start this a little earlier, so the temperatures are still pretty high. I have 5 thermocouples running along the length of the reactor, and that's going to be for later whenever I use the data, the temperature profile collected from this reactor to fit to a finite volume method simulation to determine the pre-exponential factor and activation energy for the 3 main reactions in methanol reforming. But that will be for another day anyways. So the reactor is still pretty hot at 50 degrees Celsius in the middle, which is expected. And I ran this about 5 minutes ago, so the ceramic fiber blanket and aluminum foil are certainly doing their job. And I've already checked continuity between the thermocouples and the live wire there, and there's nothing. And there's no continuity between the live wire and the pipe itself, and it's also grounded. Anyways, so I'll go turn on power. And then have this voltage regulator here. And you'll see it kick on. There we go. So I'm going to adjust it to around 50 volts, which should give about 200 watts of heating. So we'll watch the temperatures. You can see that they're climbing rapidly. That 4th thermocouple kind of worries me. There may be a short, but I made sure that all of the heating wire was spaced evenly. So hopefully that doesn't become an issue. But I'm going to wait for it to get up to around 200 degrees Celsius, and then I'll start injecting water into it. So I guess we'll just wait for that. Specifically, I'll probably wait for the 4th thermocouple to reach 200 degrees Celsius, or at least for the first one to get above 100, maybe 110. Anyways, so yeah, we'll just wait for that. Yeah. This is the first time I'm going to let it reach above, actually I guess this is my first time heating it above 100 degrees Celsius. So yeah. I'm hoping we'll probably see some smoke coming up through the reactor due to some adhesives or anything else that can't withstand the temperature in there, which I'm sure there's a little bit of. hopefully not much. One thing that, gee, that's above 100. Okay, I'll turn the peristaltic pump on. There we go. So you can see the water is running down. And I'll turn up the voltage. 224. It's definitely going in. I'm going to back up a little. Okay, we should see a temperature drop on the first thermocouple pretty soon. That is going to be some very hot steam, so I'm actually going to turn off the heating now. Actually, that's falling pretty fast, so I'm going to turn it up again. I did leak test this before, so hopefully that still stands after... Oh, there we go, there's steam. Look at that. That's great. Oh my God. So, wow. Oh my God, that's amazing. Wow. I can't believe it. So I'll have to go back to the recording and see how long it took from the water actually going into the reactor to the steam coming out to roughly estimate the residence time. Although that's not very high velocity steam, although it's pretty clear coming out of the outlet, so it must be pretty hot. I'll just put my hand over it a little. Yeah, it's pretty hot. About what you expect from a kettle. I'm hoping that pressure is not building up inside of the reactor. Hopefully not. What I'm also worried about is the second thermocouple being significantly hotter than the middle one. Maybe that's just due to closer wiring spacing in that area, but I really hope it's not a defective thermocouple, because if it is, I'm gonna have to rip this entire thing apart, which is not gonna be fun at all. Yeah. It works. I can't believe it. This is about 100 times better than my previous experiment went. I'm gonna turn up the heat a little. I think I can get it to, yeah, I'm gonna get it to around 100 volts now. So that should be around 500 watts of heat. And you can see the steam is moving out of the reactor with a lot more velocity now. And I will turn it up a little more. Yeah. I was honestly expecting there to be more smoke from adhesives and other things burning off in there, but I guess I did a good job in making sure that didn't happen. So yeah. I could probably, to make it, to get a more saturated steam, I could probably turn down the flow rate of the pump here. Oh, okay, I'm gonna turn it off. I guess it's not hot enough. Oh, please don't short something. I'm gonna turn off the power now. That's not great, as it means that I'm not getting a lot of heating. I really hope that doesn't short something out, but it'll probably be dry in the morning. See how hot. I turn off the power, right? Turn it off here, but I'm gonna unplug it just to be very sure. There may be a resistor, or not a resistor, a capacitor somewhere, so I'm just gonna if there is a capacitor, I'm just gonna discharge that, but I don't think there is. Anyways, yeah, I can touch it. It doesn't even feel that hot. It's sort of warm. I could go get my temperature gun and actually see what temperature it is, but it feels about 30 degrees Celsius, which is very good considering that the internal temperature is around 113 degrees Celsius right now. And I still don't know why that the second one is reading such a high temperature. And I'm kind of worried now because it might mean that that thermocouple actually is defective, which is not great. Anyways, see ya.